So this is going to be how we're going to write the names for the ionic compounds. We already did writing the formulas. Writing the names is a little bit easier. There are two naming systems that we currently use. One is called the IUPAC, and it's the one that uses the Roman numerals to give us the charge or the oxidation number of those ions. Remember I said iron could be a +2 or a +3, so we have to put that Roman numeral with it so we know which charge it has. There is an old system of naming that we sometimes still see, which we're only going to do it so you can kind of notice it, so if it shows up somewhere you can kind of look here and see. And it is the us and ich system. It is the oldest system, but it's still sometimes commonly used. It's only used on positive ions that have more than one charge. So here are just four of the most common examples. We have copper, and copper is going to be a +2 or a +1. The ich is always for the higher charge, okay? So this would be cupric, okay? And if you always wondered why copper is Cu, when it's because it's from the old Latin name of cuprum. And then the +1 would be cuprous, okay? And then tin can be a +4 and a +2, and they are stannic. And now you know why tin has that SN. And it's stannous. Iron can be a +3 or a +2. So we have ferric from the Latin word of ferrum and ferrous. And then lead can be a +4, and we call that plumbic, or a +2, which is plumbous. And we saw that on one of the earlier slides, and I said skip it for now because we hadn't done this yet. Okay? So, writing the names from the formulas. First thing, for binary, again, remember, is one metal and one nonmetal. The correct full name of the cation is used, which is the metal ion. So it's written first. We don't change the name. And if it needs a Roman numeral, then we're going to do that. It says, do not forget the Roman numerals if it is copper. Okay, but there is more than that, okay? Basically, it's your transition metals can have more than one charge. And so you have to be able to include that Roman numeral, with the exception of zinc, which is always a +2, and silver, which is always a +1. So we will not give those two Roman numerals. So you have to know those two exceptions, okay? Then comes the anion. The last syllable is changed to IDE. So if I have chlorine, I change it to chloride, just like we did in the binary. Just like we did in molecular. Okay, so for example, sodium and chlorine would become sodium chloride. If I have copper CuS, first thing I have to do is I have to determine, do I have copper 1 or do I have copper 2, because it's a transition metal. So I can look, what I do is I look at what it's bonded with. What it's bonded with is a sulfur, which I know is a 2- because of where it's located. So that means the fact that I only have one copper with it, I must have copper 2 because their charges are balancing out. So let's do a couple of examples. All right, so some of these are mixed in. I'm just going to do a few of these. So first one would be magnesium chloride. That's it, just magnesium chloride. The reason that we do not use prefixes for ionic compounds is because they can only go together in one way. I'm just going to start over. That's messy. So because they can only go together in one way, we only have to name them one way. There's only one way that magnesium, which has to lose 2 electrons, can go together with chloride, which has to gain 1. So it takes 2 chlorines to balance it out. Okay? Let's skip down here and do this one. Sodium and phosphorus. So I have 3 sodium, but because that's the only way it can go together, I would just call this sodium phosphide. Okay? Never put a prefix on a metal. That'll help you. Never put a prefix on a metal. Okay? Never, ever, ever, ever. Okay? Next one would be, let's drop down here because this is going to need a Roman numeral. So I have iron, which I know can be a +2 or a +3. So I need to look at what it's bonded with, okay? And I know that iron is plus something, and nitrogen is a 3-, okay? And since I only have one iron with it, that must mean that I have 3+ iron. So I would need to write that as iron 3 nitride. Okay? I'm going to drop down here and do zinc sulfide. Zinc is one of those exceptions. I know it's a transition metal, but it can only be a +2 charge, so this would just be zinc sulfide. Okay? Let's go over here and do calcium nitride, because that's on your paper. Okay? So that's the only way those can go together, so I would say calcium nitride. Now your notes are missing some of the examples, and for some reason some of the polyatomics got mixed in there with them. Okay? So I'm going to skip to the next page and talk about how you do ternary, which is with the polyatomics. And basically it's the same thing. Okay, so the ternary, which is meaning you have a polyatomic, is going to be the same thing, except never change the ending of the polyatomic. So if it's phosphate, it stays phosphate. If it's sulfate, it stays sulfate. So let's do a couple of these to name. So this is just simply going to be sodium phosphate. Because phosphate is a -3 charge, it took 3 sodium to go with it. Okay? This one is going to be aluminum sulfate. Just name what you see, unless it's a transition metal. This next one is copper nitrate. But is it copper 1 or is it copper 2? So what we have to look at is we have to know that nitrate is a -1. The fact that it only took 1 copper and 1 nitrate must mean that it must be the +1. So we would call that copper 1 nitrate. Here we have Pb, so we know lead can be a +2 or a +3. I'm sorry, a +2 or a +4, but we know that carbonate is a -2, and the fact that it only has 1 lead means it's got to be lead 2. So that would be lead 2 carbonate. Okay? Now I kind of want to give you a different example than's listed on here that might make this a little bit easier to understand about the charges. So let's say, I'm going to show you 2 examples. I'm going to show you FeO and I'm going to show you Fe2O3. Okay? We know that oxygen is a -2, or 2- rather. Okay? So the fact that in this compound it only took 1 iron to go with it, I know that I've got iron 2 oxide. But in the second compound, it took 3 and 2. So if I have 3 total oxygen at a -2, my total charge is a -6. So that means I have to have this side also be a +6. So the fact that it took 2 of them means that I've got iron 3. Because 6 divided by 2 is 3. So this one would be iron 3 oxide, which is rust. When you see rust on iron, that's what it is. It's iron 3 oxide. Okay? All right. So that's how you write the names from the formulas. It's not much different whether you're doing binary or polyatomic. Just don't change the names of the polyatomics. Don't ever give a metal a prefix, okay? Also, don't give the prefixes to the polyatomics here either, okay? So you're going to do the other half of your worksheet where you're writing the names, and then I will see you guys when I return.